So what are piecewise functions? Let me get it open. Okay. What are piecewise functions? Here's the definition. In the notes, definition 27. A piecewise function is a function that is defined by two or more functions. So just like last time, we have more than one function and we're gluing them together to get a new function. And it's a little bit different than last time because what we're doing is each subfunction is defined on a separate interval of the main function's domain. So last time we were gluing functions together by taking an x value and feeding it through more than one function or adding the functions together. This time we are splitting up the domain. That's what I would say we are doing. We are splitting the domain into pieces. We split the domain into pieces and we apply a different function on each piece. And here is the first example, exercise 55. We have a function. This function has three pieces. I'm going to call this thing the first piece. I'm going to call the next one the second piece, and I'm going to call the last one the third piece. So this one function f is made of three pieces. It's made of three subfunctions. And depending on what the x value is, you use a different function. So if you're used to computer programming, it really is an if statement. If x is less than 1, you use the first piece. If x is between -1 and 2, you use the second piece. If x is bigger than 2, you use the third piece. And so when you feed in a different x value, you go to the right piece, you plug in, and you see what happens. That's what you had to do in Math1030. So I only have 63 answers in Math1030. Put your hand up if you haven't had a time to do it yet. Let me give you guys another minute to do the Math1030 for people who came in right at 4:30. And maybe I'll very quickly make some super quick announcements. So make sure on Monday there's homework, and there's also that's the last day for the high school algebra quiz. So if you haven't done that, make sure you write that down. You got to do that before Monday. Okay, there's like 10 seconds left. Who needs more time still? Anybody for more time? A couple people? Okay. There's only a couple people, so I'll stall a little bit, and if you're still putting in your answer, put it in now before I press the button. Okay, so f of -3 is the first one, f of -3. So what you have to decide is which branch to use, and -3 is less than -1, so we're going to use the first branch. So to do f of -3, we're going to do the first branch. So we're going to do -3 plus 1, because the function is x plus 1. So whatever x is, we add 1. -3 plus 1, that's -2. Let's see what people said for this one. And I'm going to reveal the counts. All right. Okay, lots of people said 2. 11 people said 2. Is -2? -2, very popular. So great job, guys. Most people got -2. I guess if you got 2, maybe you put it in the wrong branch. Like the middle branch is 2. So if you put it in the wrong branch, maybe you got 2 by accident. It is the first branch, or the first piece. I guess it's called piecewise. Maybe we should call them pieces. That one's -2. Let's do the next one, f of 4. And 4, the number 4 is bigger than 2. The number 4 is bigger than 2. So we're going to use the third piece. I shouldn't do it in green. I should do it in purple. Purple. The third piece. So 4 is bigger than 2. We use the third piece. The third piece says you take the number, you subtract 4, you square it. So it's 4 minus 4 all squared. The first 4 is the x. X is 4 here. 4 minus 4 squared, 0. How many people got 0? How many people got 0? 0, pretty popular, 45 people. I guess that is right around half, maybe a little under half. Some people still stuck on 2. 2 would be the middle branch. We're in the second branch. What other errors do people make? I guess maybe some people didn't have enough time. You guys should tell me when you're out of time. I can give you more time. All right. I don't know what other errors were made. Okay, what's the last one? The last one. Lots of people said 2 for this one, and that one is right. It is right. So let's reveal the answers here. The last one is 2 because x equals 0 is the middle branch. X equals 0 is the middle branch. X equals 0. So 0 is between -1 and 2. So we're going to do the second piece. So we get 2. It's just always 2. The middle piece is always 2 no matter what. So we're using the middle piece. We get 2. So the answers are -2, 0, and 2. Let's see, I guess, yeah, lots of people. So around 60% of people got it right here. 55% of people got it right here, and 60% got it right here. So maybe you guys mixed up the branches. I don't know. What other mistakes or things were not clear? Yeah. How did I get f of 0? Oh, why is f of 4 equal to 0? Oh, why is f of 0 equal to? Okay, yeah, let me do that one again a little bit slower. So the first thing you got to decide is which branch you're using. Maybe we could get the people in the back to talk a little more quietly. Okay, so you got to decide which branch you're using. F of 0, so x equals 0. And when x equals 0, we got to decide, are we in the first piece, the second piece, or the third piece? That's what you have to decide. And 0 is between -1 and 2. So the answer is it's the second piece. And so because the answer is the second piece, whatever the function says to do, we're going to do. Whatever it says there in the green highlighted region, that's the answer. Sometimes it says x plus 1. Sometimes it says x minus 4 squared. Whatever it says to do in the second piece, we do. For the second piece, it happens to be the boring function where it's always 2 no matter what. And so the answer is always 2 no matter what because that's what it always is. That's 2. Okay. Yeah. Good question. Anybody else? So these are piecewise functions. This is what they look like algebraically, and you got to get used to this algebraic point of view. I guess let me do the other numbers here. Let's do f of pi. And first step you got to always do is pi less than -1. Is pi between -1 and 2, or is pi bigger than 2? All you need to know is that pi is around 3 to know that it's bigger than 2. So this is the third piece. And so you're going to get pi minus 4 squared. That's whatever it says to do in the third piece. That's what we do. F of -0.5. -0.5 is between -1 and 2. So this is the second piece again. Second piece. So it's always 2. Always 2. There's a show that I really like called Silicon Valley where they throw a ball and they say, always 2. Always 2. That's this function. Okay. F of -100, which branch is that? F of -100 is the first piece. And that is because -100 is definitely less than -1. So we do the formula, which is take the number and add 1. -101 plus 1, -100. So those are the answers. Let me see if I made any mistakes. No, it looks good. Okay. Those are the values. That's how you do it with algebra. The next thing we're going to see is how to graph it. How do we graph a piecewise function? So you can take a stab at it yourself. I'm going to start by drawing the axis. And we have an x-axis and a y-axis. And just like our function algebraically had 3 pieces, our graph is going to have 3 pieces. Right? So we're going to split the x-axis, that's the domain, into 3 parts. And what are the 3 parts? There's the part where x is less than 1. There's the part between -1 and 2. And there's the part bigger than 2. So what are the 3 parts? Let's draw them. And let me draw them with a nice dotted line to split them up. So there's -1. There's 2. There's x equals -1 and x equals 2. And now we've divided the domain into 3 parts. I'm going to draw the middle piece first. That one's easy, in green. And that's the function, always 2. The function always 2 looks like this. Okay, y equals 2. That's the green function. And I only drew it between -1 and 2 because the function only exists between -1 and 2. That's where it is. Okay. Y equals 2. That's the middle piece. What about, let's do the first piece next. In blue, let's do the function x plus 1. So what you got to do is you got to draw a graph of x plus 1 goes here. So whatever x plus 1 looks like, we're going to draw a picture of it. What does x plus 1 look like? Well, when I draw x plus 1, the way I imagine y equals x, I know how to draw a 45-degree line, and I add 1. What is adding 1? Well, you go up by 1 unit. So what I would do, and don't write this down until I'm done, because the people in the class this morning or earlier got mad at me that I drew over here. This is y equals x plus 1. Y equals x plus 1 looks like that, right? It's like a slope 1, and it goes up by 1, right? That's what we would draw, except for we don't want all the stuff in the middle and on the right. We only want it on the left. So that's why you should not copy it down until I'm done, because we only want this part of the function. So we only want this part of the function. So this is the graph of x plus 1. That's what it looks like when x is less than -1. If you were to extend it, right, it would go on forever. If we were going to extend it, it would go on forever and ever and ever, like that. But we're not doing that. We're only doing that piece. So that's why it looks like that. Y equals x plus 1. And it has a 0 at x equals -1. When x equals -1, x plus 1 equals 0. So that's good. That's one piece. Okay, we need the last piece. The last piece is the third piece. It's the graph of the function x minus 4 squared. How do you graph x minus 4 squared? Well, you start with the graph of x squared, and then we're going to move it over 4 units. So this thing is 0 at the point x equals 4. So here's x equals 4. The graph is 0. And it's a quadratic equation, a parabola that comes out of x equals 4. So what does it look like? It looks like this, and it kind of goes on forever and ever, like that. It goes on forever. On this side, you have to stop when you hit x equals 2. And the reason you stop when you hit x equals 2 is because the third piece only goes for x values bigger than 2. So it really does look like this. If you were going to keep drawing it forever and ever, you would keep going, but like that. But we aren't going to do that because we stop at 2. So there's the graph. Here's the graph. Made of 3 pieces. It's a piecewise function. It has 3 algebraic pieces. It has 3 visual pieces on the graph. There is one thing, one detail that is in the algebra right now. If you look at the algebra carefully, the detail is there, and that detail is missing in my graph. I didn't include it in the graph. What detail do you guys see that is maybe here, but is not here? Here's the detail. Yeah. The inequalities, what about them? I definitely have between 1 and 2. That's perfect, yeah. So some of them are inequalities with an equal sign, like less than or equal to 1, and some of them don't have an equal sign, -1 less than x, right? And I said between 1 and 2, I did a good job of handling between 1 and 2, but I never specified, is it equal to 1 or not? So I kind of left it vague and like imprecise on this graph, and that's because I haven't finished yet. The detail we need to add now is what happens at the endpoints. So what happens at the endpoints? At the endpoints. That's the question we got to answer. And in algebra, you do this by saying less than or equal to. It has a very specific meaning. On a graph, you draw a dot, and you either fill it in or you don't fill it in. That's what you do. So you do this, draw dots. Draw dots. Okay, so we're going to draw dots, and we're going to draw the dots. They're not filled in when you exclude the point, and they are filled in when you include the point. So first piece has an equal sign. There's an equal sign right here. And so I'm going to draw a dot, a big filled in dot at x equals 1. And it's filled in because we're including -1. -1 is included on the blue graph, so it's a filled in dot. On the second piece, x minus 1 is a strict inequality, right? It's x strictly bigger than -1. Equals is no good. We're excluding x equals -1 from the green graph. We're excluding it from the green graph. So it looks like this. It's an open dot. We don't fill it in. And that is telling everybody we're excluding it. And look, it makes sense. You cannot include x equals -1 on both the blue and the green graph. Otherwise, it wouldn't be a function. Only one of the two could be filled in. In this case, it's the blue one is filled in and the green one is not. Okay, what about at x equals 2? Let's go read what happens. So at x equals 2, we have this strictly, x is strictly less than 2. X is not allowed to be equal to 2, and that's on the green graph. So we draw another big circle. Okay? And on the last purple graph, x is greater than or equal to. This is a greater than or equal to, and so we draw it filled in purple. Okay. And of course, when you do it, normally you don't use 3 colors. You draw it all in black or whatever color your pen happens to be. But that is the graph of the function, and you can see the 3 pieces. OK, that's the graph of a piecewise function. It goes with the algebra of a piecewise function. Questions or comments about this one? Yeah. Yeah. So this is a great question. If this was on a test and I said, what is f of pi? Pi minus 4 squared is great. If I wanted decimals, I would say, give me decimals. Yeah. Yes, it would say, give me this. Or I would say, like, there would be like multiple choice, and there'd be like a bunch of options or something. Yeah. Yeah, that's great. Yeah, so there's no need to simplify something like pi minus 4 squared. It's perfectly fine. OK, the last question you can answer, what is the domain of f? And the domain of f is all the possible x values, right? So even though we have these 3 pieces, those are not the function, right? Like you shouldn't say the domain of the function is minus 1 to 2. Only the domain of the green piece is minus 1 to 2. What is the domain of f? It's everything. It's everything between minus infinity and infinity. And that's because everywhere on the x-axis is in one of the 3 pieces, right? Green has all the points between minus 1 and 2. Purple has all the points bigger than 2. And blue has all the points less than minus 1. Everybody is covered in this particular example. What is the range? OK, the range is the same idea, but for the y values. OK, all the negative y values are covered by the blue graph. The blue graph gets all the negative numbers. And the purple graph gets all the positive numbers, right? So between the blue graph and the purple graph, we have covered everything minus infinity to infinity. The green graph also covers 2, but we already covered that, so it doesn't help. OK, so the domain is everything. The range is everything. Piecewise functions. The world's most famous piecewise function is the thing we're doing next. This is the world's most famous. This is like the influencer of piecewise functions, the absolute value function. Most famous piecewise function. What is it? It's drawn like this with 2 lines. And you have to know that the 2 lines means this special function. Here is the definition of the piecewise function absolute value of x. F of x, it's one thing if x is bigger than 0, and it's another thing if x is less than 0. So it has two formulas, one for bigger than 0, one for less than 0. This is what the graph looks like. For x bigger than 0, it's just x. If x is a positive number, I don't touch it. I just give you back x. If x is a negative number, I do negative x. That's what it is. Here is something that your brain will get confused by. Here's something your brain will get confused by. I wrote negative x. And then on the graph, it is above the x-axis, above x-axis, x-axis. Right? This is the piece. The green side of the function is this. That's this guy over here. It says negative x, and then I drew it above the x-axis. What is going on? I thought you said negative, right? The other side is perfectly fine. Y equals x. That makes perfect sense. Y equals x. Why on earth is this silly thing negative x? It's got a negative sign. How could it be above the x-axis? Does anyone know? Yeah. It's the y-axis. So it's when you say it's still on the same side? So we're on this side, and it's above the x-axis. I think I didn't understand your question. So I'm just saying the y values are positive, but we have a negative. What's going on? Yes. OK, yeah. OK, this is a point. So I think this is one way to understand it. If you just kept this guy going forever, it would go down there. So that's one way to look at it. Did somebody else? Yeah, up here. It's absolute. This is true. It is absolute value. So this is one way to look at it. Absolute value. We're talking about the absolute value function today, and you might know the absolute value function makes things positive. It's absolutely, absolutely right. It makes things positive, but what I want to explain to you guys is how this formula works. Because it's very easy to get bamboozled by this formula, and that's why I'm hyper-focusing on this minus x, which is very confusing, or can be very confusing if you don't know the secret sauce of the minus x. So that's why I'm trying to get you guys to think about this minus x formula and how it could be that minus x is positive. There's another, yeah? You're multiplying a negative by a negative. I really like the way you said that. So negative x looks like in your brain that's a negative number, right? You're like, negative x, negative number. Great. Negative x is a positive number. Negative x is a positive number. So this is the thing you got to watch out for in the absolute value function. Of course, in the blue side of the function, it's all hunky-dory, it's fine. On the green side of the function, negative x is a positive number because x is negative, because x is negative. So don't get confused by this. The absolute value function always makes things positive. How could it always make things positive if it has a negative sign right in the formula? The reason a negative number is the positive number. There's two negative signs. One of the negative signs is hidden in here. X is less than 0. X is a negative number. That's why we have negative x. It's actually positive. And so like the colloquial thing that people think of is they say the absolute value function just makes things positive. This is how it's defined mathematically. It has a negative sign, and the negative sign exactly cancels out the negative in the x. So you have two negatives, a double negative. So watch out for that. Very easy to get confused by that. Everybody makes that mistake. Okay, so we've understood the absolute value function. Any questions or comments about that? Yeah. 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 Yeah, no, this is a great point. Let me go over this. So the question is essentially, what would happen if I was missing a piece? So here I have 3 pieces, and it happens, the reason the domain was everything is because the 3 pieces cover everything. That is the reason the domain was everything. In a different situation, like imagine we had the function with only the first and the third piece. Like imagine that the middle piece was missing. If the middle piece was missing, then the domain would not be everything. It would only be all the numbers up to -1 and all the numbers bigger than 2. So if you're missing a piece, then you're missing a piece in the domain as well. And that can totally happen. That can definitely be a thing like, here's a function, tell me the domain, and the answer is you're missing all the numbers in the middle. Yeah. That's a great way to phrase it. It is the union of all the pieces. And so it's the union of all pieces. Yes. Because the function is like all the possible things that can happen. And if you have a bunch of pieces, you could be in this piece or that piece or that piece. That's the union. Very good point. Okay. Okay, we're going to go back to the absolute value function. The absolute value function, again, it covers everything. So the domain of the absolute value function is everything because between these 2 pieces, we have everybody covered. Here is the next problem. We're going to look at the piecewise function x minus absolute value of x. And we want to graph it. But before we graph it, we want to find the formula. Find the formula. Okay. And I'm going to give you guys some hints, and then I'm going to set you free on Math1030 to try to do it. So here's my hint. Is just my starting hint is let's just rewrite what is the absolute value function. So the absolute value function is something if x is greater than 0. It's something else if x is less than 0. It's x if x is bigger than 0, and it's negative x if x is less than 0. And now if you simplify, I'm going to get to something if x is bigger than 0, something else if x is less than 0. I want you guys to think about it, fill in what the 2 question marks are. And essentially, I'm asking you to do this simplify step, which is simplifying a piecewise function. You've probably never done that before, but if you think logically about it, I think you will discover the right way to do it, and it will help you learn how simplifying with piecewise functions works. So take a stab at it. I'll open it up in Math1030, and you can try it. Okay, there's like 15 seconds left. Who thinks they need more time? Anybody for more time? Let me add 30 seconds here. Okay. Let's see what you guys think. Let's reveal some answers. What did people say? So a lot of people in the first blank said 0, 26 out of 84. I guess around a third of the people said 0. Some people said 1. Remember, your answer might depend on x. Minus x was popular. Some people did it with a lowercase x, but they did a plus x. So we got some x's, some minus x's, x squared. Y equals 0. I guess y equals 0 is the same as 0. So 0 seems to be most popular here. And what about down here? Okay, here 0 again, somewhat popular. 1, 2, 3, 4, 5, 6. Some people said 2x. Some people said x. Some people said x squared. Some people said minus 1. So no answer is close to a majority here, right? Like a majority would be like 40 people. The highest ranked answer has like 20. So I think this one is a bit confusing. So let me give you some more hints, and then we're going to revote one more time on what's going on here. And I think, like rightly so, we're trying to combine two functions, right? We're trying to combine a function which is a piecewise function with a regular function like x, which is not piecewise. How can you possibly combine these things? One of them has this like if statement, if x is bigger than 0. The other one has no if statement. Like how do you possibly combine them? Well, the answer is you just like add in some if statements for this guy. So why don't we force this guy to work? Why don't I write x? I can write the function x like this. X is equal to x if x is bigger than 0, and x is equal to x if x is less than 0. So a very like silly way of writing x. X is either x or x. Okay, yeah. But why is it helpful? Because now it matches the other guy. It matches the other guy. And now I have the pieces are lined up, right? If you're in the x greater than 0 piece for the first guy, if x is bigger than 0, these pieces line up. And if x is less than 0, those pieces line up. So now maybe we can combine them a little bit better. So now with that hint, maybe you guys can try it one more time, and let's get the final answer. So what is it? It's something if x is bigger than 0, and it's something else if x is less than 0. Okay, and this minus sign came out a little funny. Let me rewrite that. Okay, so let me freeze that up there. Maybe that hint will help you guys. And I'm going to reopen this. So I'm going to make you guys vote again on this one. Okay, so it's open again. Even if you don't want to change your answer, you have to put in you have to type it in one more time. And let's do a minute here. Okay, 15 seconds left. Put in your guesses. What could it be? If you get 1 out of 2 of them, that's still good. Okay. All right, let's take a look. What did people say? This time, is there a majority on one answer? Okay, we're up to 31 people in 0. 10 people think it's 1. Minus x is also popular here. 2x is a possibility. That's for the first blank. But 0 has under half the people, but is the most popular. What about this one? In this one, 2x has 13 people, minus 2x has 2 people, minus x has 14 people, minus x has 17 people. So I think some people maybe are, the most common mistake I'm seeing is people are misunderstanding the question. So what I would like to do is I would like to combine, I want to combine this with this. I have 2 things and I want to smash them together. And look, this one is x if x is bigger than 0, and I'm subtracting x if x is bigger than 0. So if x is bigger than 0, what do we get? Well, this one gives you an x, this one gives you an x. So what do you get? You get x minus x. X minus x. So that is going in the top over here, x minus x. So I think people who wrote minus x or wrote things like that, maybe you were just looking at just that piece. But I wanted the 2 pieces combined, right? I want to say what f of x is, and that's the combination of the 2 things together, and the 2 things together is x minus x. And if you simplify x minus x, that is indeed 0. That is 0. So that's 0 if x is bigger than 0. So if you wrote 0, you got the right answer. Not many people wrote it, so I want to be crystal clear about why it's 0. It's 0 because we're combining 2 things. One thing is x, the other thing is x, and what are we doing? We're subtracting them. X minus x, 0. That's the right answer. What is the answer in the other part? The answer in the other part, let me reveal the answer here. The answer in the other part is, okay, 0, 42% of people, and this one, 2x, only 18% of people got. Only 18% of people got. So some people, again, had the mistake of just doing 1/2 of it. Some people made a minus sign mistake, which also happened earlier today. What else? Minus x, this is on the right track. They're just forgetting one thing. What happens? We're combining the 2 things together. We're combining the 2 things together. So what you should get is x. That's this x, right? This x. Then you got to do this minus sign, minus, and then you got to do minus x, minus x. So the answer is x minus x. So a lot of people wrote like half of that. So you were probably missing some of the terms. The key thing to watch out for, it's minus x, right? Minus x. And minus is a plus. This is the thing, so it's 2x if x is less than 0. So that is the final answer. 0 if x is bigger than 0, 2x if x is less than 0. And we're going to draw it in a second. But is the algebra, is that making sense now? You see how to do it, how to combine the things? Yeah. Yes, I absolutely can. Yeah, I'm happy. So I have a little button here that freezes the screen, and I'm happy to use that anytime. So just you guys tell me that you want me to keep one up there. I can always do it. Okay. The next thing we're going to do is we're going to draw it. So we're going to draw it. Okay, actually, maybe let me pause a little bit longer for questions here, because so I know not many people got it right. Some people were on the right track. Like if you wrote minus x or minus x, you were forgetting the first x. Like you forgot that x, or you forgot that x and made a minus sign mistake. So you were on the right track, but you maybe misunderstood the question. I know it's a little tricky. Questions, comments, anything I can clarify here? Okay, so let's draw the graph. And once again, it's very tempting. We're going to draw the graph. Okay, y equals 0. This one I know how to draw. I can draw y equals 0. Like the best y equals 0 you've ever seen. Y equals 0. Over here, y equals 0. That's this part of the function. If x is bigger than 0, y is equal to 0. So it's a horizontal line. What about this half of the function? What about this half of the function? 2x. It's very tempting to say 2x. 2x is positive, right? 2 is positive, x, so maybe 2x should be a positive thing, right? Do that. Don't draw this. Don't draw this, because it actually looks like this. 2x, this is y equals 2x, is right here, is that piece. So that is what the graph looks like. 2x is negative, again, because x is negative. It is double of what we drew last time. So it's this dotted line down here. This was y equals x. And we have y equals 2x. So that's what it looks like. Two pieces, one of them is horizontal, and the other one is this negative thing. And some people were confused by this last class. How could x minus absolute value of x be negative? Well, we're subtracting an absolute value. It's a negative negative. That's why, there's a lot of negative signs. That's the final answer. Yeah, questions about this graph? You can also check it. This is a really good idea to do that we also did earlier. You can always check these things. It's a great idea. Check them in Desmos. So if you type in x minus line x line, Desmos knows you're talking about absolute value, and it draws the graph for you. And it looks just like we said, line piece, horizontal piece. Okay. Questions or comments about absolute value? So we're going to do one other thing with absolute value, which is what happens when you do the absolute value of a function. So this is the absolute value of f of x. And just by writing out what absolute value is, the absolute value of a function, it's the function if x is positive, so it leaves it alone if positive, if f of x greater than 0, and it flips it if negative. Okay, it flips it if negative. So what does this look like? I will tell you without too many details. What does the graph of just x squared minus 4x look like? It is a quadratic equation. It goes through x equals 0 and x equals 4. So x squared minus 4x, oh boy, that was quite the miss. Okay. Okay, we got 2 in a row. Okay, good. Y equals x squared minus 4x is that blue graph. And what does the absolute value look like? So the absolute value, y equals the absolute value of x squared minus 4x. What does it look like? Well, it's a copy of the x squared minus 4x graph. You leave it alone. You do nothing. You do nothing if x is positive, if f is positive, rather. So less than 0 or bigger than 4, it's exactly the same function. So far, all I've done is I have copied it over, right? But when the function is negative, when it's below the x-axis and it's negative, then you have to flip it. So you have to flip this thing over here, and that becomes this function. You flip it like this. So that is what the graph looks like. We've taken the bit of the function that is negative, and we've flipped it by multiplying by a negative sign to make it positive, right? This is really the idea of making something positive. You flip it if it's negative. And that's what it looks like. Once again, if you're ever doing problems like this that are visual, always a good idea to have Desmos help you out. X squared minus 4x looks just like that. So you can see it's a quadratic equation where the bottom bowl got flipped over to make it positive. Okay. Was the graph helpful? I don't know. I can leave the graph up. There you go. Questions or comments about that one? Okay, we're going to move on to another concept, which is even and odd functions. Oh, this procedure is what I just said out loud. What I just said about flipping. What I just said. So you can read it if you want, if you like words. Even and odd functions. The next couple sections are all about adjectives that you can apply to functions. And even and odd are the first two adjectives we're going to learn. These are like functions with special properties. Functions with special properties. And we're going to see that even and odd, even though they sound like numbers, like even and odd, they're kind of weird names. They're types of functions that have certain symmetries. So we're learning about different functions and different symmetries they have. Even is one type of symmetry, and odd is another type of symmetry. So the first one we're learning is even. And an even function, what does it mean for a function to be even? It means that it has this property. F of minus x equals f of x for every possible x. That's what it means to be even. What does this have to do with symmetry? This is some kind of crazy equal sign for the function. Here is why it has something to do with symmetry. So graphically, if f of minus x equals f of x, then the height of the graph at x equals x and minus x are equal. So when you draw the graph of the function, maybe the function looks like this. When you draw the graph of the function, on the graph you have the point x f of x. And over here you have the point minus x f of minus x. So the statement f of minus x equals f of x means, what does it mean? It means it's the same height. So saying that the function is an even function, which is algebraically saying f of minus x equals f of x, is the same thing as saying when you draw the graph of the function, you have the same height on one side of the x-axis as the other side of the x-axis. Another way you could describe this is you could say the graph of f mirrors itself. Graph of f mirrors itself. And what is it mirroring across? Across the y-axis. So the graph of f is a mirror image of itself. It's the same height on both the one side and the other side. You could draw it by doing a mirror image. And it has to, the definition says it has to be true for all the points. So all these points are the same height on the graph. That's why it's a mirror image of each other. That's why even is secretly saying it's a symmetric function about the y-axis. I don't know who decided. Oh, I do know who decided. I'll tell you why they call it even. Let me tell you why they call it even. Even is a silly name, but here is the reason people call it even. Y equals x squared is an even function. Y equals x squared is even. Okay, I'm sensing some people would like this saved. Let me do that. Y equals x squared is even, and in fact, any even power is even. So y to the x to the 4, y equals x to the 4 is even, x to the 6 is even, x to the 8 is even, x to the 10 is even. So all the even powers are even. That is the origin of the name even. Why is it true that the even powers are even? Well, it's because of the rules for multiplying exponents. So minus x squared, this is f of minus x, that is equal to minus 1 squared times x squared. This is on the high school algebra quiz, due Monday. Minus 1 squared times x squared is the same as minus x squared. You pull the minus 1 out. What is minus 1 squared? That's minus 1 times minus 1, negative times a negative, that's positive. So this is just the same as x squared. And x squared is equal to f of x. So what we have shown algebraically is that f of x and f of minus x are the same thing. And because of that, the function is an even function. You can see that in the graph of the function, it has this symmetry about the axis. The same property holds for cosine. The same thing holds for cosine. So cosine, also even, also even. Why is cosine of x even? Well, the mathematical answer, cosine of x is even because cosine of minus x equals cosine of x. Okay, but why? But why? I will post why in an extra video. So if you want to know why, I will post an extra video and I'll explain why. The reason is I want to get to, we had even functions. What is the arch nemesis of the even functions? The odd functions, the odd functions. Okay, what are the odd functions? Again, it's a type of symmetry. It's slightly different. What type of symmetry is it? Instead of f of minus x being equal to f of x, it's negative f of x. So there's this extra important negative sign in front. F of minus x is no longer f of x, it is negative f of x. So what does this say graphically? I think let's just skip straight to the picture. I think the picture is better than the words. Okay, so here is the function, and here is the point xy. On the graph of the function, if the function does some crazy stuff like this, that is the point x f of x, right? So y equals f of x. And you are telling me that x f of x is on the function, If I looked at minus x, that would be the point minus x, f of minus x. And so saying that f of x equals, what am I trying to do? I'm trying to do f of minus x, okay. Saying that f of negative x, oh no, we're running out of time, guys. Saying f of x is negative f of x is the same thing as saying